Hello everyone, welcome back to Learn Then Code. It's so great to see you all here. So today's video will be about pointers, virtual functions and polymorphism. Although we have covered all these topics briefly in some of our previous videos, so for example operator overloading and function overloading that we have already learned in our previous videos is a type of polymorphism, and pointers we also have covered in our data type video. But in this tutorial we are going to learn about them more deeply. So let's see what is the meaning of polymorphism. Polymorphism means one name but multiple forms. So something that has multiple forms is known as polymorphism. And now I hope you can understand why I said that we have already covered this thing in function overloading and operator overloading. Because if you remember, if you can recall, in function overloading we had the same function name but their prototype was different. So for example, if I have two functions, let's say display, the first display does not take any argument and does not have any return type as well, and in this we are just printing hello. Okay, then let's say we have another display function which has one parameter in the argument list and return type as void, and we are printing hello plus a. Okay, a very simple example I am taking. So here the name of the function is same, still the compiler know that these two functions are different because their prototype is different. There is some difference in either the return type or the argument list, right? So this type of polymorphism is known as compile time polymorphism, static binding or static linking. What it means that at the compile time, compiler knows which function to call at which function calling. So for example, if I am calling this function from my main code, int main, and I am calling display function without any argument, so the compiler knows at the compile time that I am going to call this particular function, and if I have some integer in the display function as an argument, then the compiler knows that I am going to call this particular function. So this kind of polymorphism is known as compile time polymorphism. Although it is polymorphism because the name of the function is same, but still the compiler knows the difference at the compile time. So this is one thing. Now there is another kind of polymorphism which is known as runtime polymorphism. So we want that instead of compile time, at the runtime, compiler will be able to distinguish between different forms of same function. So for example, if I have a parent class A which has a display function. Now this parent class has, let's say, three subclasses B, C and D, and all these subclasses has their own display function. Now what we want that depending upon the type of object we are creating at the runtime, the compiler will be able to call that particular class's display function. So we do not want to use class resolution operator, we do not resolve the ambiguity from ourselves, but we want the compiler to do it for us. So this type of polymorphism is known as runtime polymorphism or dynamic binding or dynamic linking. So here the interesting thing is that the complete prototype of the function is going to be same. There will be no difference in the argument list and in the return type, because in inheritance, as you can recall, we rewrite the definitions of a function, right? We do not change the prototype of a function, but we can rewrite the operation that we are going to do from that particular function definition. So this is the particular use case, and this is what known as runtime polymorphism. Now let's see how can we achieve this. So before learning about polymorphism, we have to first understand about pointers. So pointers is a very interesting data type because it does not store a data type value, rather it store the address of the data type that we want to assess or that we want to use in our program. So let's understand this via an example. Let's say I have a memory location with some address, for example, let's say XYZ right now. Although the address is always in hexadecimal form, but right now I'm taking a very easy example. Let's say it is XYZ. Now I have stored 2 in it. Okay, now I want to have a pointer variable that is pointing to this particular value. Now how can I do it? I will store this XYZ value into this particular memory location, although this is also a memory location, but instead of storing data in it, I'm storing data address, right? And then I can call this particular memory location is a pointer, and it is pointing to this value. So first thing is, pointer is a derived data type. It is not primitive like int, char or float, double, etc. It is a derived data type. Next thing, it refers to another data type, another data variable. Now this data variable can be user defined, can be derived, and can be primitive as well. So you can point to any of the various type of data types, whatever you want to point to. And the very basic definition of pointer, if you want to learn, is a pointer variable defines where to get the value of a specific data variable instead of actually defining the data. Now let's see how can we declare and initialize a pointer. One thing very special here is, so normally what we do, if you want to initialize or declare a int variable, you will write int a, right? If you want to have a char type, then you will write char a. But here we will write the type of the kind of data type that we want to point while defining the pointer. So for example, if I am writing int asterisk p, that means p is a kind of pointer that will point to int type of data type. For example, just we have seen, so we have stored 2 in this particular memory location, and this pointer is pointing to 2. Hence, I can declare this type of pointer as int asterisk p, and p will be the name of this pointer. So that's how you can declare your pointer. And again, here you can have even the primitive data types, for example int, char, float, double, etc. You can have structure as well, structure, classes, or any other user defined data type, and you can have pointer of pointer as well. So for example, if this is a pointer, I can have a pointer that is pointing to this pointer. So it will become something like this. Now what this means is, this means that x is a type of pointer. This first is asterisk. X is a type of pointer that is pointing to this type of data type, right? That is pointing to this type of data type. Now if you look at this data type, this is again a pointer which is saying that p is a data type which is pointing to int. So we come at this, then this. I hope you got the point. How can we declare the pointer and how it works. Now let's see how can we initialize a pointer. Now you know that we store the address of the memory location in pointer. Now to get the address, we use the address of operator, which is denoted as ampersand. Address of operator or reference operator. Now for example, I have declared a variable a and initialized it with 2. Now I want to declare a pointer to this variable and want to initialize it, of course. What I will do is, I will simply say int asterisk p. That means that p will point to the type int. And to initialize it, I will say ampersand a. That means in p, store the memory location of a variable. Simple, right? So that's how you can declare and initialize the pointer. Again, treat the pointer as the addresses value. So all the operations that you can perform on addresses, for example, incrementing the address, decrementing the address, or adding some numbers to the address. So all these operations you can perform with pointers as well. Now one small thing to note here is, you can declare the pointer like this or like this as well. Both are correct. Either you can have the asterisk before the your variable name or just after your type name. Both will work fine. Now let's quickly see a small program on how can we do manipulations with pointers. It's a very simple program. We have our main function. Here we have defined a variable a. So we have a memory location. The name of that memory location is a, and we have stored the value 10 in it. We have a pointer of type int. So we have a pointer. The name of this pointer is ptr and the type is int. That means it will point to a data of type int. Now we have initialized this pointer to the address of a. That means this pointer will point to a. It will have the memory location of a, something like this. Now what we are doing is, after clearing the screen, we are printing the value of a first using the variable. So we are directly printing a in it. So the first value would be a. As you can see in the output, the value is 10. Now what we are doing is, we are doing some manipulation. Let's understand this statement. First of all, this thing will evaluate first. So we will first evaluate the expression and then we will do the assignment. That's how the things will work. That's how the compiler understand this particular statement. So let's understand. Asterisk ptr divided by 2. This is the thing. This is the thing. So first what we are doing is, we are dereferring our pointer. This particular thing, it means that we are referring to the value this particular pointer is pointing to. So here this particular thing will change to 10 because ptr is referring to a, right? So it will change to 10. Then we are dividing it to 2. That means the answer is 5. Now this statement has changed to asterisk ptr is equal to 5. Now again asterisk ptr means a. So this statement will again change to a is equals to 5. Every time you will see asterisk ptr, right? Asterisk pointer, asterisk p, x, anything with asterisk, please understand that we are dereferring the pointer. So if you are declaring your pointer and writing int asterisk p, that means you are declaring your pointer, and if you are writing asterisk p directly, that means you are dereferring your pointer. You are actually trying to assess the value this pointer is referring to. So every time if you are confused to decode this particular thing, try to change the asterisk p to the value it is referring. So let's see. Let's say we have this particular statement, right? Asterisk ptr is equals to asterisk ptr divided by 2. Now what I will do is, I will change asterisk ptr to a, because in our case ptr is referring to a only, right? So this statement will change into a is equal to a divided by 2. Simple. Yeah, so this is the very simple thing that we are trying to do through pointer. We are not actually assessing a, we are not changing a directly, but we are doing it through pointers. So that is a very good example, and I hope you have got some clarity on how can we use pointers to change the value of a data type. Just a note that this asterisk symbol is known as indirection operator. So for example, if you are using this operator something like this, let's say 1, that means you are using this indirection operator, right? If you are using %p or %a, then you are using address of operator or reference operator. Okay, so this is just the naming of these operators that you should know. Okay, so now having an understanding on pointers, how can we use them in our program? Let's understand about polymorphism, the main thing that we are going to cover in this tutorial. So for that, I will give you a scenario and you have to think on that particular problem and you have to come up with the solution that you have in your mind based on all the knowledge that you know till now about OOPS. Okay, so now I have a class. This is a media class and it has 3 subclasses. It has images, it has books, and it has, let's say, tapes. Okay, and everyone has their own special properties, and some common properties like ID of the media, and let's say author, or in case of tapes you can have singers or anything else, but let's say let's be common and say author for all the types. So this is the basic structure. Now we have a display function in all the four classes. I have a display function here, then I have a display function in images, then in books, and then in tapes. Everywhere I have the same display function, and the prototype of this display function is also same. Now this is all the data members definition and the structure of your classes. Now in the main function, what I am doing is I am asking the user to choose the type of object he or she wants to create. And how I can do is I am simply taking an input from the user and checking if a is equal 1, and I am assuming for if it is 1, I am creating the object of type images. Okay, so let's say I'm creating new of images. Similarly, if the input is 2, I am creating the object of books. Similarly for tapes as well. So that's how you can do it at runtime. I hope you got my point. How can we create objects at runtime based on the type of input that we are getting from our user. Now you have to understand one thing. All this thing is running at runtime. You don't know that whether the user will give you the input 2, 3 or 1, or maybe some invalid input. You don't know about it. It will compute at runtime. So now if I will call a function, display function, how will the compiler know which display function to call? Whether it's the display function of images, books or tapes. It will come to know only at the point of runtime, when the compiler know, okay, actually which object was created and which function to call. So now if the user has given me the input 1 and I have created the object of image and I am calling this image display function, then only the compiler will understand that okay, I have to call the display function of image. Again, if the input is 2, then I have to call the display function of books. So that's how it will work. All this thing will work at runtime, and this is known as runtime polymorphism, because all these things is running at runtime only. Now how can we achieve this? It's very simple to do. You just have to define this display function as virtual in your base class. You just have to write this virtual keyword when you are defining this function in your base class. So it will help the compiler to understand that okay, this function is going to be virtual. This function can have multiple copies or multiple multiple forms in my subclasses, so I have to perform the relevant operations before actually calling the function definition. So that is how polymorphism works. Now let's see the actual code. Now let's understand this. We have a very simple scenario. We have a base class. The name of the class is base. Now we have a derived class, only one derived class, and the name of that derived class is derived. Very basic case. We just have two functions, display and show, and both these functions are available in your base class as well as in your derived class. So we have a display function and show function in our derived class as well. And one thing to note here is the prototype of your function for both the cases, for both the functions display and show, is same in your base class and in your derived class. So here there is no argument list, there is no return type for both the functions. Just one minor difference of this virtual keyword. So in the display function we do not have a virtual keyword, but in the show function we have this virtual keyword. Let's see the difference that this virtual keyword can make. Let's go to our main code and interpret it one by one. So in the first line we are declaring the object of our base class. So this is of type base. The name of this object is B. In the next line we are declaring the object of our derived class. Okay, this is derived class. In the next line we have declared a pointer that will point to base type, which means there is a pointer. Of course it is a pointer type, that means it will store address only, but we know that it is going to store the address of a variable of type base. This is clear. Okay, in the next line we are just printing that this pointer is going to point to base type. Now we are initializing the pointer and we are saying that this pointer is going to store the address of our B object. That means this pointer, the name of this pointer is bptr, is going to point this particular object, right? Now in the next line what we are saying is call display function. Now here come the decision time. Will the compiler call the display function of your base class or your derived class? Okay, so the answer is your base version will be called. Why? First, the type of this variable is of base. This is first thing. The second thing is you haven't used virtual keyword in your display function. That means you are not informing your compiler that there are other forms of this function as well. So you are not actually informing your compiler that there can be an instance of runtime polymorphism. So the compiler has done this mapping at the compile time only based on the type of your pointer. So in the pointer declaration you have mentioned that the type is going to be of base. That means at this calling compiler will understand that okay, the type of this pointer is base. That means you want to call the display function of your base class. Irrespective of the type of object this pointer is going to point. Okay, so this is one thing. First is the type was base. Second is there was no virtual keyword in the function prototype. So because of these two things your base version will be called. Now in this show also your base version will be called, because again you are pointing to your base object and you are calling your show function. Now here comes the interesting point. What if instead of storing the address of my base object, if I start pointing to the derived object? Because see, this derived object is a type of base as well. It is derived from your base class. So you can point to your subclass using the pointer of your base class. It is a valid thing and you can do it. So now let's say you have changed the value of your base pointer and now you are pointing your derived class, and now you want to call the display function. This is a tricky question. Please take a moment and think about it. So here if you are calling display function, your base version will be called, but if you are calling show function, your derived version will be called. This is interesting. What is the difference between the two? Just the virtual keyword. So for the show function you have defined it as virtual, but the display function you are not using the virtual keyword. So you are not actually informing the compiler that there is a possibility of runtime polymorphism. So you have to bind your function calling and your function definition at the runtime. So what will happen, based on the type of your pointer, if you haven't defined your function as virtual, the compiler will bind your function calling, which is in this case is display, and your function definition, which is in this case is this one, together at compile time, because this is not virtual, right? At the compile time we know that the type of this pointer is of base asterisk only. So it will, start pointing to base function classes. But in the show case, you have defined it as virtual. So you are informing the compiler that wait and do the mapping at the runtime. So what will happen, based on the type of address you are storing at the runtime, the compiler will decide the kind of function you want to implement. So in this case, your derived version will be called. I hope you got the basic idea how this runtime polymorphism works. Now, as we have understood how can we achieve runtime polymorphism using virtual functions, there is some criteria that we have to keep in our mind while defining virtual functions. So let's see the rules of defining virtual function. The first rule is that the virtual function must be a member of some class. The second point is it cannot be static. Now the third thing is they are assessed by using object pointer. As we have already seen in our example, we are using pointers because it is going to happen at runtime. The fourth point is a virtual function can be a friend of another class. So there is a concept of friend function, so a virtual function can be a friend function as well. The fifth point is a virtual function in a base class must be defined even though it may not be used. The sixth point is the prototype of your base class version of virtual function and all the derived class version must be identical. Again, because I'm repeating my point, because if these two are not identical, then the compiler will take it as function overloading, which is a compile time polymorphism, not runtime. So to use runtime polymorphism, you have to keep it in mind that the prototype of your function should be completely identical. The seventh point is we cannot have virtual constructors, but we can have virtual destructors. So we have already covered what are constructors and destructors. You can check out the videos on constructor and destructor in the same playlist. Now the eighth point is, while a base pointer can point to any of the type of derived object, as we have seen in our previous example that we had our base pointer. So this was of type base pointer. It can point to base class, but it can also point to derived class. Now the next point is, when a base pointer points to a derived class, incrementing or decrementing it will not make it to point to the next object of the derived class. Now let's understand about pure virtual function. So pure virtual function is also known as do nothing function because we define it as something like this. We say that this function is equal to 0. That means there is no definition of this particular function and it is virtual in nature. That means the subclasses will redefine this particular function, but the base class has no definition. It is pure virtual. So in these rules, we have seen that a virtual function in the base class must be defined. So this is a way how you can make it pure function if you don't want to define it. You can simply say that this is pure virtual function and all the subclasses have to redefine this particular function in their own way. And when you define a pure virtual function in a class, by default that class will become an abstract class. And if you can recall, in the previous video we have defined what is abstract class. So an abstract class is such a class which cannot define its own object. Okay, so if you are defining a pure virtual function in your class, that class will by default become your abstract class. What is the use case of having the abstract class or defining the pure virtual function? So they will serve as a placeholder. So you will say that okay, this is a virtual function and I have defined in our base class. Now every subclass that will derive me have to redefine this function. This is a kind of placeholder that you are telling the compiler that okay, you will find the definition of this particular function in all my subclasses. This is the use case of having pure virtual function. And again, the same thing with abstract classes. Why we don't want to create the object of abstract classes? Because they are simply playing the role of a template. We are storing the common things that we have in our subclasses in our abstract class, but we are not going to create any object of that class. So that's why we declare the particular class as abstract class. So it is acting like a template, and same goes with your pure virtual functions. If you do not have a definition of your function in your base class, then you can definitely define it as pure virtual function. So yeah, that's it for today's tutorial. Thank you for watching it till the end. See you next time.